In this question, you can see that there is a boy which takes 60 minutes to swim across a river, and if his goal is to minimize the time. So obviously, if he wants that he should cross the river in minimum time, then that minimum time is 60 minutes. So we know that the minimum time formula is W by VB. So W by VB is equal to 1 hour. And if he wants to cross the river in shortest path with zero drift, then the time taken is 180 minutes, and we know that 180 minutes is 3 hours, and 3 hours is equal to W by under root VB square minus VR square. So in this question you can see that he is able to cross the river in 180 minutes with zero drift, which means that he can cross the river with zero drift. And for to cross the river with zero drift, it is necessary that the speed of that swimmer should be greater than the speed of river current. So option A is correct and option B is wrong. Now we know that these two are two equations. So if the width of the river is 3 root 2, then the speed of river current is 4. So first of all, if the width is 3 root 2, then VB is equal to 3 root 2 kilometer per hour. And if VB is 3 root 2 kilometer per hour, then this is under root VB square, which is 18 minus VR square. So this is at 18 minus VR square is equal to 2. So VR is equal to 4 kilometer per hour. So C is also correct. And in D option, if he crosses the river which is 3 root 2 kilometer wide in 60 root 2 minutes, then he will be carried root 2 kilometer downstream. So in this case you can see that this 60 root 2 time is greater than the minimum time, but it is less than the time taken to cross the river in shortest path. So obviously we can say that neither he is moving like this and nor he is moving in this direction to in such a way such that drift is zero. So he would be moving somewhere between these two directions. This is the direction in which he should swim so that he should cross the river in shortest path, and this is the direction in which he should swim so that he cross the river in shortest time. So in this case he would be moving at some angle in this direction. So if this angle is theta and this is VB, so we can say that VB cos theta is this velocity and this is VB sin theta. Now the width of the river W is equal to 3 root 2 kilometers, and the time taken is 1 root 2 hours, or we can say just root 2 hours. So VB cos theta is equal to W by T, and W is 3 root 2 by root 2, and VB we have already calculated VB as 3 root 2. So this is 3 root 2 cos theta. So you can see that cos theta is 1 by root 2 and theta is therefore 45 degree. So if theta is 45 degree, then the drift will be del will be due to VR minus VB sin theta. Okay, so VR is 4 and VB is 3 root 2 and sin 45 is 1 by root 2. So this is 1. So drift del will be equal to into time. Okay, so into time. So drift del will be equal to 1 into time. Now time in which he would cross the river is given as root 2. So this is root 2. So the drift will be root 2. So the correct answer is also D. So the correct answers are A, C and D. Now we move on the next question. In this question, you can see that there are two identical boats which can move with respect to river with a velocity of 1 meter per second. A boy which is standing on the ground observes the boat 1 to be moving perpendicular to the river flow, which means that obviously boat 1 would be trying to move like that. This is boat 1. So this is VB, and this velocity would be under root VB square minus VR square. For a boy standing on a raft which is floating in the river, so obviously if the observer is a boy which is standing on a raft which is floating in the river, then obviously that boy would be moving with the velocity of river itself, and therefore we can say that the second observer is river itself. So for river, it is observed that the velocity of the second boat is in this direction because he is going perpendicular to the stream. Okay, this is boat 2, and they are found to be at a distance of 4 meter from this point in y direction, and this is 5 meter in time t. So we have to find out the speed of river current. So obviously we can say that for this boat the distance y, this is y, is 4, and 4 will be equal to under root VB square minus VR square and multiply by time t. And for this boat 5 is the drift, in fact 5 is the y coordinate, so 5 will be equal to VB into t. So dividing these two, 4 by 5 will be equal to under root of 1 minus VR square upon this is VB, which is 1. So squaring this would be 16 by 25 is equal to 1 minus VR square. So VR square is equal to 9 by 25 and VR is equal to 3 by 5, which is 0.6. So the correct answer is 0.6. Now we move on the next question. In this question, you can see that there is a man in a boat which starts from point A and wishes to reach the point C. You can see the dimensions of these points, and the speed of river is VW. So we have to find out the minimum speed of the boat relative to the water and at what angle that he should swim or he should row his boat so that he could reach C. So let us suppose that he is trying to swim or trying to move at an angle of theta here, and then due to the drift of river he reaches this point C. So this is the actual path and this is the path on which he is trying to move, or I can say that this is the path relative to the ground and this is the path relative to the river. So you can see that the component of VB on this line is VB cos theta. So this is VB cos theta, and here the component is VB sin theta, and the river velocity is VR. Okay, so now the time taken by this boat to cross the river would be B upon VB cos theta, and the drift is A, so drift would be due to this velocity. So it would be VB sin theta plus VR into time. Now we have already calculated the time, so it would be VB sin theta plus VR into B upon VB cos theta. Okay, now we have to find out VB from this equation. So A by B is equal to you can see that it is tan theta plus VR by VB cos theta. So you can see that VR by VB cos theta is equal to tan theta minus A by B. Okay, now VB will be equal to, you can see that VB will be equal to VR upon sin theta, B sin theta. I am taking the LCM, minus this would be A cos theta, and here it would be B. Okay, so VB is, I am writing it again, so VB will be equal to BVR upon B sin theta minus A cos theta. Now we have to minimize this VB and we should find out theta. So dVB by d theta should be 0. So it would be minus VB, in fact B into VR divided by B sin theta minus A cos theta whole square multiplied by B into this is cos theta minus this would be equal to minus minus plus A sin theta, and this would be equal to 0. So you can see that tan theta is equal to B by A with a negative sign, which means that the true direction in which he should move is this one. So this should be the angle theta, and if this is if we consider that he is moving in this direction at this angle theta, so then tan theta, in fact this angle is alpha, let's suppose. So alpha is equal to minus theta, so tan alpha will be equal to B by A. Then cos alpha will be equal to B by under root B square plus A square, and sin alpha will be equal to, in fact this is A, and sin alpha will be equal to B by under root B square plus A square. Now you can substitute these values in this equation. So VB minimum is equal to VB into VR, this is B into VR divided by B into sin theta, which is B upon under root of B square plus A square with a negative sign. Okay, so you can see that in this equation you can easily watch that this is VB by V, and there would be a negative sign here. Okay, so there would be a negative sign, and here it would be a negative sign, and therefore there will be a negative sign. So it is minus because we are substituting the value of theta, not alpha. So sin theta would be negative and cos theta would be positive. So this is A square upon under root B square plus A square. So V minimum will be equal to, this is B VR upon under root of B square plus A square. So this is the minimum velocity with which he should move, and the angle should be this one, alpha. Okay, so if we measure this angle with the direction of flow, then it should be 90 plus alpha, and where alpha is tan inverse B by A. Now we move on the next question. In this question you can see that there is a boat which is moving with a uniform velocity of 20 meters per second. This boat is pulling a water skier with the help of tug rope of length 10 meters. To increase the speed of himself, this water skier tilts the ski slightly away from the direction of motion of the boat. As he do so, the tug rope rotates. So what is the speed Vs of the skier with respect to the ground in this position, and the angular velocity of rope? Now let us draw this diagram, that this is the rope and this point is moving with the velocity of Vb, which is 20. This angle is 30 and this skier is moving like that, Vs, and this angle is 60. So obviously we know a fact that any 2 points on the rope, on a stretched rope, would move with the same velocity along the rope. So the component of these two velocities, this is 20 cos 30 and this is Vs cos 60. These should be equal. So 20 cos 30 should be equal to Vs cos 60. Okay, so you can see that Vs would be equal to, this is 20 root 3. Okay, this is Vs. Now we have to find out omega. So let us see that both these 2 points are moving. So to find out the angular velocity omega, let us see that this velocity is, this point has a velocity in this direction and this point has a velocity in this direction. So if we find out a point which is perpendicular, if we find out a point, if we draw these two perpendiculars to these velocities, then they would meet at this point somewhere like that. So let us say that this is the instantaneous center around which these are rotating. So let us suppose that angular velocity is omega. So you can see that this angle would be 30 and this angle would be 60. And let's suppose that this is RA and this is RB. So RA cos 30 and RB cos 60 is the difference of these two is equal to L. L is 10. You can imagine that if you draw a perpendicular, I'll draw a new diagram for you. You can see that this is A, this is Vs, and this is VB. So if you draw these two perpendiculars and if you draw this line, then this is RA and this is RB. This angle is 30, this angle is 60. So you can see that this component would be RA cos 30 and this would be RB cos 60. So RA cos 30 minus RB cos 60 is equal to L, and L is 10. So RA into root 3 minus RB is equal to 20 because L is 10. Now you can also see that VB by RB is omega, and omega is the angular velocity, and Vs by RA is also omega. So these would be equal. VB is 20 root 3 and this is RB, and Vs is 20. In fact, VB is 20 and Vs is 20 root 3. So RA will be equal to root 3 RB. So if we substitute this value here, then you can see that 2 RB is 20 and RB is equal to 10. So omega will be equal to VB by RB. So VB is equal to 20 and RB is 10. So omega will be equal to 2 radians per second square. In fact, per second. So this is the angular velocity of the rope. Now let's move on the next question. In this question, you can see that there are two motorboats which moves with velocity of 4 meters per second and 6 meters per second relative to water. They are going in upstream in a river, and when faster motorboat overtakes the slower one, then a buoy is dropped from the slower boat. Buoy is a floating object, and after some time they both turns back simultaneously and moves with the same direction relative to the water. Their engines were switched off when they reached the buoy again, and the maximum separation between the boats is 200 meters after the buoy was dropped. Now the river velocity is 1.5 meter per second, and we have to find out the distance between those two points at which the faster boat passes the buoy. So let us first of all draw the scenario that let us suppose that river is flowing in this direction with the velocity of 3 by 2, and both the boats are going in upstream directions. So this is 6 and this is 4. Now there was an anchor which was dropped in the water. This is in fact this is a floating anchor. Okay, it is not anchored to the floor or to the bottom of the river, but it is a floating anchor, and obviously therefore it would be moving with the velocity of river. So if we draw the diagram with respect to river, then we can say that with respect to river, these velocities are 6 and 4, and the time t is the time when they turn back. So in that time t, this boat A would have moved by a distance of 60 and it has moved by a distance of 40. So the separation between them is 2t. So you can see that after this point they will turn back, and then this will move in the backward direction with 6 and this will move in the backward direction with 4. Then the distance between them will start to decrease again. So the maximum separation between them is 2t, which is given as 200. So t is equal to 100. So t is the time in which they turn back. So you can easily imagine that if the anchor is at rest, because we have drawn the scenario of river with respect to river. So anchor is at rest because anchor is the part of the river. So if this boat is taking t time to go in the forward direction, then it would take the same t time to come in the backward direction. So that anchor, while floating with the velocity of river, would have moved by a distance of Vr into 2t. So x will be equal to Vr, which is 3 by 2, and 2t is 200. So x is equal to, this is 300. So the distance at which this anchor will move in this 2t time will be 300. So the correct answer is C. Now we move on the next question. In this question, you can see that there is a river whose width is B is equal to 320 meters, and there is a boatman at A which is moving in such a way such that he is always moving towards B, always. So the velocity of boat with respect to river is given as 5 by 2, and velocity of river is given as 3 by 2. Now its motion would be like this, that initially it would move in this direction and then the river will drift it slightly. Now at this point it will still move towards B point and the river will drift it slightly. Now after some point at this point it will again be moving towards B and river will drift it in this direction. So let us draw a scenario that this is B and this is A, and at this point this boat is moving towards B with velocity VB, and this is VR. This angle is, let's suppose, theta. So you can see that this angle is also theta, and the approach velocity of boat towards point B will be VB minus VR cos theta. Now this approach velocity, let's suppose that this distance is L. Okay, so V approach will be minus dl by dt, and therefore it would be VB minus VR cos theta. Obviously theta is variable, so dl will be equal to, minus dl will be equal to VB minus VR cos theta into dt, integrating both the sides. The limit of L is the relative separation between boat and point B, and you can see that initially this boat and point B were separated by a distance of B, and finally when they will meet, then that distance will become 0. So let's suppose that in t time it will happen. Then using this negative sign we can interchange the limits, and limit will be B and it is Vb into t minus integration Vr cos theta dt, and limit would be from 0 to t. Now you can see that b is equal to Vb into t minus Vr. We will take Vr as common, and here it would be cos theta dt. Limit will be from 0 to t. Now this is obviously variable quantity theta, and we cannot establish any relationship between theta and time. So we could not find out the variation of theta with time, and therefore we could not integrate this function. But you can see that initially this boat was on y-axis and initial coordinate of boat was 0, and finally it reaches the point B, and therefore final coordinate is also 0. So x initial of the boat is 0 and x final of the boat is 0. Therefore the distance traveled by the boat in x-axis is delta x, which would be 0. So I can say that the velocity of boat at any time in x-axis would be Vb cos theta in backward direction and Vr in forward direction. So the net velocity of the boat in x-axis is Vb cos theta minus Vr, and this would be equal to dx by dt, where obviously dx is 0. So Vb cos theta minus Vr into dt is equal to 0. Okay, now integrating these functions, so you can see that cos theta dt limit from 0 to t is equal to Vr into t divided by Vb. What I've done, I've integrated this also with time limit 0 to t, and I have divided it by Vb, and this is the value which we need. So we can substitute this value here. So b will be equal to Vb into t, and there would be a negative sign, minus Vr into t by Vb. So t will be equal to b Vb upon Vb square minus Vr square. So t will be equal to, b is 320, Vb is 5 by 2, and Vb square minus Vr square will be 25 by 16 minus 9 by 16. So it would be 1, and therefore you can see that the time will be equal to, in fact this is 25 by 4 minus 9 by 4. This is not 16, this is 4. So this is 4 and this is 4. So it is this is 160 into 5, 160 into 5 divided by 4. So this is 40, 40 into 5, 20. In fact 200. So the time taken by the boat to reach point B is 200. So the correct answer is 200. Thank you.